Hi everyone, it's been a little while, and for that I apologise. The reason it's been so long since the last update on the upcoming indie game Station 77 is because my team and I have been working very hard actually just building the game. As a result, I have a lot to tell you about today, but first and foremost, you can now wishlist Station 77 on Steam. There will be a link at the top of the description, so please go and put it on your wishlist. It costs nothing, only takes a few seconds, and it really helps us for two reasons. Firstly, the more people wishlist the game, the more our game goes up in the upcoming new releases category, which means more people see it. Brilliant. And secondly, we can point to that number of wishlists when we're talking to publishers and say, hey look, people want to play our game, give us money to finish making it. I feel like indie dev content creators maybe don't say this enough, but wishlisting the game isn't just a reminder for you when it comes out, it also genuinely supports us and helps us make the game even better for all of you. Now, with that out of the way, let's talk about all of the hard work that's been done on the upcoming indie game Station 77. Starting off simple, we split the levels up so that instead of loading everything into one single map all at once, which is very inefficient, we instead load a fairly sparse persistent map which features floors, outside walls, things like that. Basically anything that needs to be constantly loaded in because it can be viewed from anywhere, or would stop the player getting out of map bounds in the unlikely event that an actual level fails to load for whatever reason. Then, we load each sub-level into or out of that core map based on location or event triggers. Conveniently, Unreal Engine has an existing system for this called the level streaming system, which handles all of the ugly technical stuff, and utilising that saved us a lot of time faffing with low-level data. This turned what I was dreading being a month-long job into just a couple of weeks. The initial setup only took a couple of days, but then I got stuck on a bug where I couldn't manually trigger load or unload events. For any other developers out there looking to use this system, the thing to watch out for, if you're having a similar issue, is that the load stream level by name or reference functions and the level streaming volumes are mutually exclusive. I lost a week trying to work out why I couldn't control the load and unload of maps with the manual function call, and it's because their state was being overwritten by the streaming volumes. I just solved this by creating a custom level streaming volume, which was just a collision box that invokes the load stream level by name method when the player interacts with it. This has the additional benefit of allowing me to do stuff before I unload a level, which is useful for reasons we will talk about next. So, having partitioned up the levels, I noticed that everything seemed to stop working all at once in subtle and frustrating ways. Keycards suddenly stopped working on the doors that they were clearly linked to, doors were no longer correctly restoring their locked or unlocked state when I would save and load the game, pushable object positions were being reset. I mean, what on earth was going on? Now might be a good time to say that I've actually never had to work on level partitioning before. My previous projects were all single map mechanic prototypes, and the level design work I did on task time was A, almost entirely greyboxing, and B, broken up into separate, reasonably small maps that you just load up. There was no world partitioning to speak of. Here is an interlude in the video to say that at time of writing, Task Time is now available for public playtest. I did a teeny tiny bit of work prototyping levels on this like 2 years ago, but more importantly it is being made by people who I know who are very cool and skilled, including featuring lots of 3D work done by Saskia, who is doing the 3D work for Station 77. So if you're looking for a new friend slot type game, you should go and play the playtest for Task Time and wishlist it ahead of release. It is genuinely super fun and the team has done a great job with it. Okay, that is enough free marketing. Back to my game. We've split all the maps up into separate files and suddenly nothing works anymore. These two things are somehow related, but how? The astute and technically competent among you may have already formed a hypothesis, but it took me several weeks of debugging and one fairly significant crash out in which I achieved very little to realise that when the levels were being unloaded, they were being unloaded. I'm dead serious, it took me an embarrassing amount of time to realise that unloading and then reloading an object through the level stream system is functionally identical to spawning that object for the first time. It only has the default starting parameters that you pass in. The reason this had broken the load game feature is that when you load the game, all of the maps have their data reloaded sequentially, and then everything is unloaded again for optimization before it loads in the map that you were on when you saved. So it's saying to a door, hey you're actually unlocked, and the door goes, okay, sweet, and then the door gets obliterated from existence and resummoned seconds later with no memory of any of this. The fix for this is actually reasonably simple, and conveniently improves the save load system at the same time. I'll break this down in non-technical terms for the non-techie people in the audience who are interested in how games work. So, the requirements for fixing this system are to know when a map is about to be unloaded, stash all the data somewhere that's not going to be unloaded, and then when a map is loaded, fetch and restore all of that data correctly. We have a list of maps which are full to the brim with our juicy data. When we unload that map, all of it disappears. So what we're going to do is give each map a unique manager whose job it is to make sure all of the data in their assigned levels is organised, and create a persistent global manager whose job it is to keep track of the per map managers. So, when a map is loaded up, the manager pops into existence, and the first thing they do is go around to all the objects in their level and assign unique IDs to them. These IDs are calculated based on the location of the object in 3D world space, so they're not only unique, but also reliably reproducible across restarts of the game. Then the per map manager goes to the global manager and asks, "Have you got any stored data for me?" If we assume here that this is the initial setup that happens every time you start the game, the boss manager says, "Nope, not a thing." The per map manager then gets his clipboard back out and goes around to each object and takes a note of all their important data in a big sheet with the UID at the top, like a test paper where you put your name at the top and fill in your answers. The map manager then goes back to the big boss manager and hands in all their paperwork. Big boss manager stores the paperwork in their big file. This step is called stashing, so if I say, "We're going to stash the data," just imagine one of the map managers giving their boss manager the big register. The main menu now appears. That all happens before the main menu. Now, if we assume that the player wants to start a new game, the game loads the first level, the medical bay. The medical bay's manager gets summoned anew, goes to the big boss and says, "Have you got anything on file for me?" And this time the boss says yes. So he gives the medical bay's manager the documents from his big folder. For techie people, the folder in question is a linked list where the data structure is mapped to an enum of the level's name. And the manager goes back around to every object and says, "Hey, what's your ID?" and then restores all the object's important data from the stash. Everything is now as it should be. It's worth clarifying that this all happens intensely quickly. Here, I'll show you, in real time. So yeah, this is a pretty quick system. By the time we're finished, there'll be enough data that you might start to notice loading times of up to a couple of seconds, especially on slower hardware, but I don't imagine you're ever going to be waiting more than 5 seconds for this game to load. We'll definitely test it on some slower machines to try and get a sense of where the limits are though, and I'm sure that'll be in a future devlog. So, the player plays the game for a little while, unlocks some doors, collects some items, moves some pushable objects around, and finally progresses onto another area. Let's use the storage bay as an example, seeing as that's our second map of the game. Before we had this manager system, the player would move to the new area, the old area would get deloaded, and all that progress would vanish into the ether. While this makes for an interesting mechanic in a potential game about the horrors of living with Alzheimer's or something like that, that's not what I'm trying to do here, and therefore this is not desirable behaviour. With our new manager system, however, we can hook into the level partition system, and just before unloading the level, have the map manager go around, round up all the data from all its objects, and stash it. Then the level can safely be unloaded, and the process starts all over again with the next. The way this optimises the save load system is that, while it used to be the case that when the player saved the game, the save object would have to go around all the objects in the game and collect all of their data like Slender Man on Adderall, and then again when the game is loaded go around all the objects and reset all the data. Now, when the player saves the game, we can assume that all the unloaded levels have up-to-date stash data, so we just have to get the current levels manager to stash all the data from the current level, like it would on deload, and then have the big boss manager pass the big folder of stash data to the save game object, which writes them out to disk. Then, when the game is loaded, the save game object goes and fetches it all from disk, passes it back to the global manager, and then when we next load a map in, the per map manager asks the big boss if he has anything on file, the big boss says yes, and we essentially jump right back into the middle of restoring stash data rather than doing the initial stash. On paper, it's a reasonably simple system, and now that it's implemented, it's pretty simple to read too, but trying to puzzle it out for the first time was an exercise in headaches and caffeine abuse. All of this waffle is to say that now, when you leave an area and come back, everything will be as you left it, rather than restoring itself to how you first found it. Oh, and also the frame rate will have improved, because we're not running every single map all at once. While we're on the topic of maps and levels, let's have a chat about some of the work being done by people other than me. Robert has spent a lot of his time working on the story, which I'm not really sharing in these devlogs because I don't want to spoil anything. I'd like for you guys to experience it for the first time in the game, not have to piece it all together from stuff shared before launch. But besides the story, he has also been doing some great work on level design and puzzles, laying things out on paper and starting to greybox stuff in Engine. Because so much of it is in sketches and notes, there's actually not a great deal to visually show you, because I'm not showing you the paper maps, that would just show you how the levels go. But this puts us in a tremendous position moving forwards, as it means it's possible for one of us to build out an entire level from nothing in Engine in 1 or 2 days, as opposed to the weeks it used to take when I was just going at it with no plan. Our artist, Saskia, though she's not had a huge amount of time, has done some amazing work on assets. We've got a new terminal model, lockers, some random props to be strewn around the medical bay, and most recently this beautiful wrench, which we posted about on the Lovelace Games Twitter and Blue Sky pages, which you should also go follow for more regular updates about what we're up to. What else? The main menu now has a theme tune over it, which was composed by a dear friend of mine, and it sounds wonderful. Here's a little snippet. I also, on the topic of maps, recently made the change to using real-time lighting rather than baked lighting. This has really improved the development workflow, as we no longer have to wait ages for lighting to bake, and this time around I managed to get things set up right so the lighting doesn't tank performance. It's not ray traced or anything, we're not using Lumen, it is cheap and old-fashioned real-time lighting. It should work on basically all modern hardware and even a bit of old stuff. I don't know how far back it goes. Still need to test that. Problem now is that all my models look much too flat for this more textured lighting, so I'm really excited to see more 3D art from Saskia, though she's been a bit busy with task time leading up to their public playtest, so I'm very hopeful that the next time you see me I will be able to show you a proper art overhaul with walls and props looking absolutely incredible. Okay. This is a game, and not just data being moved around under some pretty lighting, so let's wrap up by talking about the parts of the game that you can actually play. We've added the ability to hide in lockers, so while you're exploring the environment and solving key hunting puzzles, you can hide in a locker until the scary monster goes away. The puzzles you're likely to be solving in this time may include pushing objects around, rerouting power using this beautiful new network interface wherein certain objects can be powered or unpowered, health, which is reflected in the RGB LED of your controller if your controller has RGB lights. So far I have proven this to be compatible with PS4 and PS5 controllers. I haven't got any random third-party LED controllers to test this with, so if you have one and you play Station 77, send me a photo of it working. It's worth noting that the monster still isn't in the game. That's the final really big mechanic that's still in progress and needs doing. I understand it's frustrating not seeing progress on this, trust me, it's frustrating me too. I have finally started working on the procedural movement animation system, but these things are just tricky and complicated, so it's taking a while. Hopefully that's something else I'll be able to show off next time. That section was a little bit short, but what do you want me to do? This is a systemic game where most of the gameplay is in the puzzles and environment interaction. There aren't an enormous number of discrete mechanics to talk about. Bringing this video to a close, we've talked about quite a few things. I hope if you're a fellow developer or an aspiring developer, this video has been both informative and entertaining. If you're not a dev and you're just curious about how an indie game gets made, honestly it's not very glamorous, and there's a lot of slow and steady work to get things in a presentable state. That's why these videos are released pretty infrequently. I can spend 2 to 3 months elbow deep in programming, and at the end of it, everything looks exactly the same as you're playing the game, but the underlying data that's moving around is completely different. That all being said, I will wrap up here and let you get back to your day. Thank you very much for watching. Special thanks to Carlos Eriksson, who has been sending me money to make the game. It's crazy that someone does that. Anyway, thank you very much. Wishlist Station 77 on Steam. Link in the description. You can go and do that right now. Thanks for watching. Bye bye.